Okay, so today I feel like we haven't talked about a linked list for a long time. A node pointing to a next one, right? So we can have a linked list. Of course, there are different type of linked list. If it has only one direction, we call it, single list. Okay, maybe that's not the right word, just one direction linked list. And sometimes we can have a linked list to pointing in both directions. So, then we call it doublet linked list. Double linked list, okay? With the two directions. Okay, and then you can point the last one to the first one and it becomes a cycle. Yeah, linked list like a chain, right? A chain. One points to another. Okay, so the one important thing is that we are given this head, right? We're given this head. And that's all we have. So if we want to visit a particular node in a list, we cannot directly jump to it, right? Like array in Python, you do this a equals 1, 2, 3, 4, 5, etc. Okay, this is a list, a normal list, array. We call it array, and then these information are stored in memory continuously. So meaning that I can retrieve the third one, the fourth one immediately. I can do a random access. All the random access is all one constant. You want the third item in the array, I can just give it to you by looking at it because all the data in the array in memory, in computer memory, right, are continuous, one after another. So you said, okay, you want the third one, then I can calculate the position, the address of the third one, and then get it, right? This is array. The linked list, on the other hand, doesn't provide you that. If you want the third one, right, we are given only one head. If you want the third one, how can we retrieve the third element from the linked list? Okay, so now we are here, right? Head. I want to get the third one. So for example, this is 1, 2, 3. I want to get the value of the third node. How do we do it? There's no other way, right? We can only travel step one at a time. So, okay, one step, two step, three step. Okay, now this is the third node or the fourth node. Yeah, get it? This is the difference, the major difference between a linked list and an array. So this is the array or list. This is the linked list. We want to access. Okay, we want to access random access O1 and the list will ON depending on the n, right? And the storage overhead. For the array, we don't store any other overhead, right? So we are just putting the numbers next to each other, so there's no additional space. But for the linked list, we need a additional. Why? Because we need to store on the node where it points to. Okay, so for example, this one, right? There's a little thing here. We need to store where it points to the next, which node it points to. Okay, and if you have another node to points to the previous, so we need to store additional data, which you would call it metadata. Right? Metadata is not the actual data you need, but it's very important because you need to store the pointers to the next node. Okay, linked list. Okay, so any questions so far? This linked list is not usually used nowadays because nowadays we got the big memory, right? 1 gigabyte, 1 terabyte. In the 20 years ago, yeah.
What is bigger, 1 gigabyte or 1 terabyte?
1 terabyte. 1 terabyte is 1024 gigabyte. Okay.
So
you know that
1024 gigabyte.
Yeah.
1024 terabytes.
No,
1 terabyte.
Petabyte or something.
Terabyte. Okay. And then
1024.
1 petabyte equals this. Okay.
Yeah, that's what I'm saying.
Yes. Okay.
So there's like byte.
Yeah, we talk about this. Yeah.
Byte
A byte
is
is 8 bit. A bit is basically two values, 0 or 1. Okay?
Wait, so what's 1024 byte is megabyte?
1024 bytes.
Yeah, is a megabyte.
No. This is called 1 kilobyte.
And then there's gigabyte and then kilobyte.
1024 kilobyte is 1 megabyte.
And then
10,
megabyte
24 megabyte
Gigabyte.
is 1 gigabyte.
and
Okay?
then terabyte.
Yeah, and then petabyte, and then I
Yes.
think exabyte or whatever. Okay, so now we are in a terabyte era. You know,
Yeah, but then why do some things still have gigabyte?
Then why do we even know that whatever?
Because we know it, we just don't know available.
it's a big data. You know, lot videos take space. The music, right? Whatever your
Then how
documents.
come you're saying we're
Then why is there list still like?
Then how come you're saying
Why is there still? There's why is there still?
Because yeah, good question. Yeah, one question at a time. Yes.
Be
Okay.
patient.
Yeah. Okay. So what?
Why is there still 512 gigabyte then?
102. Yes.
512, 256.
Okay, so your question, why we are in a terabyte, right? Because my iPhone, right? 1 terabyte space.
I thought we
Okay.
have 5G.
5G.
GB. 5GB.
No.
5 gigabyte cloud, yes. Okay, so it's between gigabyte and terabyte. Okay. But the data centers, they have this hard disk which is in petabyte. You know, they need to store lots of data. Okay. Okay, so why are we talking about this?
Because you said that because you said LinkedIn and like said.
Okay, yeah.
We don't really use it much because there's still lots of.
Yes,
Is
yes.
there a lot
Why?
of memory?
In the early days, 20 years ago, 30 years ago, the Super Mario again, right? That one.
Is 8-bit.
How much is it? It's
8-bit.
8-bit. An entire game was
Is
just
that-
like 20 kilobyte. And with that limited amount of memory, you can't. You can't allocate lots of memory. You need to, there's a tricks to save the memory, right? When you use it, you allocate memory. Okay, it's not like today. A picture could be a few megabyte, a video could be a few gigabyte. About 30 years ago, the memory, the Nintendo gaming, the entire memory was just like 64 kilobyte. This is the RAM. Okay? Random access memory. This is the memory of the computer. Okay? That was like 20 years ago. Now it was like the memory is from 64 kilobyte.
When are we gonna get
Okay, look.
When are we gonna get petabyte?
I don't know.
In 50 years.
Okay, look, 30 years ago, the computer memory was like 64 kilobyte. And nowadays, today, right, it's like 64 gigabytes. So how many
1024?
kilobyte, megabyte, and gigabyte? So it's not 1024. It's 1024 times 1024, right? Because in between there's a megabyte. Okay? Yeah.
I know.
So the technology evolves, exponentially in about 30 years. Okay. And because we got so much big memory, so that's why we are in a big data era. Okay, we have lots of data. We can train those data, and then that's why we have AI, ChatGPT. Okay, so let's just look at the two basic things. We want to convert the array to a linked list, and vice versa. Simple as that. It's quite simple. Okay, so how do we convert a linked list to the array? Very, very simple. While we given the head, we just walk through it until the end. And once we have this, reach the end, we have this array, right? Come on, look at this. Define list,
Linked list.
linked list,
Convert it into array.
way down to array, okay? Simple.
Why
And
two?
usually we give it a head, right? Then if not head, if we are given an empty thing, if head is none, then we return an empty list. Okay, empty list. And simple, right? So we want to return this here. Array equals empty list. While head. While head is not none, then array dot append. Right? We just push the head dot value to the array, and then we need to walk to the next node, right? Look, this is the linked list, right? Okay, now I'm here. I've appended to an array, and then I need to walk to the next one. So head equals head dot next,
Today.
and then just return array.
No, today's Friday.
Yeah,
Really? We're going to movie today.
tomorrow.
Yeah, I thought you said today.
I haven't booked a ticket. It's Mommy said tomorrow.
Oh.
So we given this linked list, the head, right? And then we want to convert it to a list. So the strategy is quite simple. We just follow the node until it reaches the end. While we're not reaching the end, we just append it to a list and then moving to the next position. The time complexity is O. So time complexity?
N.
Oh, N, yeah. N is the number of nodes in the linked list. Okay, so the other way, we are given an array, we want to convert it to a linked list. Okay, so let's write the opposite. Define array to linked list. And we're given an array, okay? Array. So how do we do this? Right, at the beginning we have to check if the array is empty. Okay? Then we return. If an array is empty, then we return none. Okay, now we want to convert it. How do we convert it? We just walk through the items in the array, and then we create each node along the way, and then we'll link to it, right? So this is an array, right? 1, 2, 3, 4, 5. How do we convert this to a linked list? Right? So the result will be 1 points to 2 points to 3 points to 4 points to 5, and that's it. This points to none. Okay. The important thing is this, right? Yeah. So we can create a node, right? So for example, like we can create a dummy node. Dummy equals this node.
Does it have to be called dummy?
Dummy, what's dummy mean? Dummy means that we are not actually returning, we just use it for now. It's a temporary node, okay? Temporary node.
So you can
And
call it,
any value could be fine. Well, let's put -1 here.
so you can call it whatever you want. It doesn't have to be dummy.
Good. Yes. Okay, then we have this current, okay? For the item I in array. So I is the number 1, 2, 3. Once we have I, so what do we have? What do we do? So we say current.next, this node, right? We create a new node with the value I. And this is the current, right? So now this is a dummy. Dummy is here. Okay? This is dummy. And also the current node is this one, the same. And then current.next, then I create this new node which is value 1. Then what should we do? Right? I don't change this dummy. I have to move to it, right? Now the current will be this one, right? So current equals current.next. For the next iteration, right? We take a new number, we create a new node. Then current.next would be 2, right? And then I need to move the current to here, right? Okay. And this goes on. And then return. What should we return? This current points to 3, current points to 4, and then current.
All of it apart from dummy.
All of it apart from dummy. So what's this? We need to return this node. Which is dummy.
Dummy.next.
Yeah, dummy.next. You see, we are not actually returning the dummy, right? We're just returning its next. So this will be the linked list converted from the array. Do you get it? And the time complexity.
N.
Yeah, it's so simple, right? Because n is the number of elements in the array. We need to walk through the numbers, okay? Okay, so what have you learned today? Simple.
Linked list stuff.
So what are these two approaches?
Converting linked list stuff.
So this one is converting a linked list to an array. This one is converting a
Array to a linked list.
Yes, and most linked list problems, if you go for software engineer interviews, they will ask you the linked list problems. The linked list problems are easy to solve because it's just one direction. Usually you walk one step at a time. And one trick is to convert the linked list to an array. And then you can solve the problems in an array. And then once you have this array, you can just convert it back to a linked list, right? Yeah, that's another way. Okay. That's it for today. Bye-bye.
Bye.
Bye.